Now that clock was slow last week. Now it's 10 minutes fast. Okay. 180-ish years ago, there's a guy named Lewis. Dr. Lewis decided to take something like that formula and make it into some kind of a structure. Now, the purpose of the structure is to give some idea, because once we know the structure, we can then kind of connote some chemical characteristics of it. So what he did is he took, this involves electrons now. He took the valence electrons and used those to construct these structures. Now, there's two kinds of electrons. We look at carbon, for example. Okay, carbon has, if you look at carbon up here, it's got how many electrons? 6. Okay. Now, of those, there are 2 orbitals those 6 electrons are in. Okay, so here's the nucleus with the 6 protons and 6 or so neutrons, depends on what isotope. So you've got 2 main orbitals. The first orbital only can hold 2 electrons. That leaves 4 left, and those occupy the remaining orbitals. Now, there are 2 kinds of electrons, as I mentioned, core, not care, core, and valence. Now, core electrons are the innermost electrons. They are super stable. Valence electrons are the outermost electrons, and they are not stable. Except for one exception. If the outer orbital was totally full, then it's very stable. That's the only exception. If it's not totally full, then it's unstable, those electrons. So what do unstable things want to do? They want to become more stable. And that's when they combine with other atoms to become more stable. Okay, so we're going to be working with valence electrons only, no core electrons for these valence structures. Okay, now I have a chart here that'll show the valence electrons are the most common elements we're going to be working with in here. This will include your next class as well. Now, I have devised a very simple way to do Lewis structures. And in your next class, they're going to tell you a complicated way to do it. And I see no reason, at least at our level, to use the complicated method. Okay, so if we're just looking at valence electrons only, all you need to know are 4 elements. Hydrogen, which has 1 valence electron. That only has 1 electron period, and has no core, only valence. Carbon has 4 electrons. Now notice there are 2 situations for these electrons. Either they're paired up or single. I call the single ones singletons. Now the paired up ones are more stable than the singletons. So they stay paired up and they don't bond with anything else, except for one exception. But normally they don't bond with anything else. And one exception is called you don't have to write this down, it's called a coordinate covalent bond. And that situation actually comes up regularly with water, but in general, it, doesn't correspond to much. Normally, though, paired electrons stay paired, and that's it. The singletons like to pair up with another singleton. That's the essence of compounds. Atoms pair up with other singletons to become more stable. Again, stability is the name of the game. All right, so carbon's got 4 singletons. Each time you have a singleton, that's a bond. So that means carbon has 4 bonds. It can be a combination of 4 singles, 2 doubles, a triple, and a single, as long as they add up to 4. Oxygen has 2 singletons and 2 pairs. Now again, pairs are going to stay paired up and they don't bond, except for that one exception, that coordinate covalent. So oxygen has 2 singletons, 2 bonds. Nitrogen, 1 pair, 3 singletons, so 3 bonds. Now I want you to notice something. On the periodic table, what is underneath oxygen? Sulfur. Remember I mentioned that everything in the group has similar chemical characteristics. This is why. It's because it has the same valence setup. Valence is the name of the game in terms of atoms becoming molecules. So if the valence is the same, then the chemical characteristics is the same. So that means right anytime now. So oxygen and sulfur have the same valence setup. 2 pairs, 2 singletons, 2 bonds. Nitrogen. What's underneath nitrogen? P, or phosphorus, okay? Notice the valence for phosphorus and nitrogen are exactly the same. 3 singles, 1 pair. Notice the singletons are in different places, so they can be moved around at your convenience. Fluorine. Fluorine has 3 pair, 1 singleton, 1 bond. Underneath fluorine is chlorine. Same setup. So really, you only have to know, and underneath carbon is silicon, and so it's going to be just like carbon. So you only need to know about 4, yeah.
Basically made out of. Why do they call it silicone and not like because I'm aware it's silicone, so I don't know what it's like why
Silicone is underneath carbon, so it acts like carbon. That's why a lot of body parts, when they make,
yeah.
fake ones, are made out of silicone, because our bodies are made out of carbon, so they want to mimic our body parts. Our bodies are made out of carbon, so they want to use something that simulates carbon. You can form a lot of different things with it. As many things as you can form out of carbon, you can form out of silicone, like stretchy gloves, for example. Fluid, all kinds of stuff. Anything you make out of carbon, you make out of silicone, because same valence. That rules valence. Okay, all right, so how do we put this stuff together? Let's look at methane, CH4. We've got carbon, 4 singletons. So you start with the atom with the most singletons. In this case, carbon. Hydrogen has 1 singleton. So what we do is we put carbon in the middle. The singletons around. We have 4 hydrogens left over. Hydrogens have 1 singleton. So that's step number 1. In the middle goes one with the most singletons. Around it are the ones with 1 singleton. Hydrogen, fluorine, chlorine, those all have single electrons, singletons. So they'll go on the outside. Now, the reason why you put the most complicated one in the middle is it's got the most possibilities of hookups. Remember, 4 singletons, we can have 4 single bonds, 2 double bonds, 1 triple and a single, all these combinations, as long as it adds up to 4. Singletons, if you just have 1 singleton, there's only one way to hook it up. That's with the single bond. There's no flexibility whatsoever with the atoms that have 1 singleton, like all the noble gases and then the hydrogens. Okay, so that's the first thing. Step 2 is to connect up the singletons into a bond. That step is to check, once we've connected everything up with at least 1 bond, are there any lone singletons that are not bonded? No. So now we check, is this legal or not? Okay. First thing, there are 2 steps determining whether it's a legal structure or not. Number 1, how many bonds does carbon have? 4. How many should it have? 4 bonds. Hydrogen has 1 bond. The other thing is you count up total number of electrons. Now remember, I said valence electrons are unstable unless the outer shell is full. And that takes 8 electrons. So let's look at all the electrons, including shared ones. We have 2, 4, 6, 8 for carbon. Okay, that means that's a full outer shell, full outer orbital. That means carbon is stable now because it's shared. Now, these are called covalent bonds. Co means share, like cohabitate. Valent, valence electrons. So covalent bond shares electrons. An ionic bond does not. I'm going to talk about those a lot tomorrow. So there's 2 main types of bonds: covalent, ionic. Now, within the shared deal, just like when you share anything, usually it's not perfectly 50-50. Usually it's skewed one side or the other. Okay, in the case of a covalent bond, it's the same thing. Uneven sharing. So most covalent bonds are called polar covalent bonds. And that means the sharing is not equal. One atom is more electronegative or wants the electrons more than the other one. Okay, all right, talk about those again tomorrow. For today, we're going to be doing covalent bonds only. Okay, so, and then the last step is to take the bonds. Oh, let me back up one. Then we count the shared electrons for carbon, which is 8, 2, 4, 6, 8. People call that an octet. Now, the problem is it doesn't apply to hydrogen, because hydrogen can only have 2 electrons total. So the octet applies to everything except hydrogen. Hydrogen, full outer electrons are full outer orbital has 2 electrons in it. So for hydrogen, does hydrogen share 2 electrons? Hydrogen is sharing 2 electrons. So hydrogen is in good shape, carbon is in good shape. So this is a valid legal Lewis structure. The last step is to take and substitute lines for all the bonds. So we have 4 bonds, 4 lines. So that's the final structure for methane. Now, I put together the series of steps. All of you taking careful notes. Where are they? Yeah. So first step is we put the one with the most singleton electrons in the middle. Step number 1. Step number 2 is connect all the atoms together with a pair of singleton electrons. Number 3, look for stray singletons, and those have to be paired up. You can't have a stray singleton. That's called a free radical, very, very unstable, very bad to have around, because they immediately become more stable by bonding with something close by. Now, in an atomic situation, that creates free radicals. That's one of the reasons radiation sickness is so bad, is because those free radicals bond with something. And they usually don't bond with the right thing. They're just unstable and they want to get more stable. So we don't want any free radicals, no singletons left unbonded. Yeah.
So if something's already stable, like what you said before, why would it want to get more stable? Already. Why is that at least?
Well, life is like that. Things go from unstable to stable. Okay. So if we have a singleton by itself, it's very unstable, so it wants to become more stable. It does that by bonding something. Now, was that the essence of your question? Okay.
Like you're having something.
Well, I mean, stable is a relative term. I mean, the world is like that. When you say something stable, there's always something more stable. Kind of like the rich. There's the rich, and then there's someone who's richer. Yeah.
Just thinking of, so not every molecule is inherently stable, right? Because I'm thinking about something like carbon monoxide, which
Is stable.
it is.
Mhm.
It's only made of 1 carbon atom and 1 oxygen,
That's right.
but its outer shell would have 10 electrons, not 8. Because
Well, the carbon monoxide is an interesting molecule. It is, if you look at carbon dioxide, it follows all these rules quite nicely. Carbon monoxide is kind of goofy.
Yeah.
If you look up the structure of it, the little structure of carbon monoxide on your phone, you'll see it's kind of goofy. In fact, on your dry lab, they ask you to draw the Lewis structure for carbon monoxide, and I tell everyone to change it to carbon dioxide. Because carbon monoxide is strange if you look it up. But it is stable though.
okay,
Unfortunately,
follow the rule.
yeah. Okay, so number 4 and 5 on here are the ones that validate whether your structure is legal or not. When I say legal, that means it follows all the rules for Lewis dot structures. Now, when you get into your next chemistry class, you're going to talk about Lewis dot structures, and they're going to give you another way to do it. Where you're going to have to total up all the valence electrons, and then you start divvying them out. And this process is much more straightforward. So you can, when you get to the next class, you can choose which process you like better. Okay, so 4 and 5, evaluate that the atom has a full shell. 8 electrons, except for hydrogen. Then number 5 says verify that each atom has the correct number of bonds. So carbon's got 4, nitrogen's got 3, oxygen's got 2, the halogens have 1, and hydrogen has 1. So if those 2 are true, you have a legal structure. Now, sometimes I can give you a formula, I'm going to do in a little while, where there's multiple legal structures with the given formula. Okay, so let's do some more here. Okay, C2H6O. Now, there are two structures we can come up with that formula. One's an alcohol and one's an ether. Both legal. Now, the quandary for a chemist is, well, which, I have this stuff. I put it in a machine and it tells me its formula is C2H6O. What is it? Well, you draw your structures and then you do some additional tests to determine whether the tests bear out whether it's an ether or whether it bears out whether it's an alcohol or not. One of them is drinking alcohol, for example, ethanol. The ether is dimethyl ether, and I'll show you those when we start building it. Okay, so let's build this Lewis structure now with this formula. Okay, so between the three atoms, which has the most singletons? Carbon. And there's two of them, so let's put those in the middle. Now, if you have two atoms that have a lot of singletons, start by putting the ones with the most singletons in the middle. And then for trying to figure out another structure, kind of mix it up a little bit. Keep the hydrogens on the outside, though. Keep the chlorines on the outside, always. Because those can only bond once. Okay, so let's start with putting carbons in the middle. All right, we've got one oxygen. Let's stick it somewhere. Let's stick it on the right. Now, oxygen's got two pairs and two singletons. Now, the singletons are the ones that are going to do the bonding. So let's keep those on the side that's closest to the two carbons and put the pairs on the outside. Again, you can move this stuff around at your convenience. Okay, then we have 6 hydrogens. Okay, so let's stick okay. So we have carbons in the middle, they have most singletons. The oxygen, it's got 2 pairs, 2 singletons, and we move those conveniently. The singletons are closest to the inner carbons, because that's what we're going to be bonding to. Those pairs are not going to bond, so they just stick those on the other side. And then we have 6 hydrogens, not 4. Okay. All right, are we all on the same page? Okay, so let's start doing some bonding. That's single to single. Now, it's good to use a pencil when you're doing Lewis structures because you do a lot of erasing. Okay, connected them all up. Now, any stray singletons? No. Okay, so let's look at the number of bonds now. Let's look at the left-hand carbon. We've got 1, 2, 3, 4. Good shape. 2, 4, 6, 8. Octet. So that left-hand carbon's in good shape. The right-hand carbon, we've got 1, 2, 3, 4 bonds again. Oxygen, it's got 2 bonds, one to the hydrogen, one to the carbon. It's got 8 electrons around it, so it's in good shape, and the hydrogens are all fine. Okay? Everyone see how I validated that? All right, next step, the last step is just put in the lines where the bonds are. So we've got carbon to carbon bond. And then the left-hand carbon is bonded to 3 hydrogens. The right-hand carbon is bonded to oxygen. And that oxygen is bound to the carbon and another hydrogen. And then carbon is also bonded to 2 hydrogens. Okay. So that's our final structure. And that is drinking alcohol, ethanol. Now there's a zillion alcohols around. Our body is loaded with it. Cholesterol is an example of an alcohol. Anything with OH on it can be an alcohol. Not everything that has OH on it is an alcohol, though. Okay, so that's one legal structure. Yeah. Oh, you're stretching. Okay, so let's see if there's something else we can do with this. Any questions so far? This takes a lot of practice. Yeah.
On the bottom of the O, and then you move them off. For your next setup, does it not matter? You can just put them anywhere.
Talk about like the pairs.
Yeah.
Then yeah, you can move them around. Move them around so it's convenient when you're drawing. Sometimes you have goofy. When you make the bond, you gotta kind of like a labyrinth. In those cases, you just move everything around so you don't have to have that weird bond. Totally free to move things around. Also, there's something called temperature. Who knows what temperature is? You've all heard of it. What is it?
Is it the amount of
It involves heat. It's a metric used to measure heat. It's also a metric used to measure something else. Yeah.
Speed at which the electrons are the atoms are.
All the above. Okay. Our world is vibrating and moving, except at one situation that's absolute zero. And by definition, that means nothing's moving. Other than that, everything is moving. And we're going to use the word temperature as a metric to determine how much they're moving. Okay. So there's, and temperature is got a bunch of different scales. Some are arbitrary and some are based on absolute zero. So by definition, absolute zero is the temperature is 0. And the scale we're going to use is called Kelvin. I have a little deal on temperature we're going to go with. Bottom line is everything's moving. Yeah. No, it doesn't, it won't. I mean, you can sort of predict humidity with it, sort of not. Humidity is a function of how much water is in the atmosphere. Okay. The more water in the atmosphere, the more humid. That's why when you go to Mississippi in July, it's awful. Or Florida in July. Yeah. Yeah, it's very uncomfortable. I find it very. Okay, so my point in bringing that up is that these structures can be drawn, as long as they're legal, in different ways. Yeah,
I was just gonna say, what about like negative degrees?
Okay,
That mean like nothing's moving?
no, no, that's an arbitrary. Fahrenheit and Celsius are both arbitrary. And based on water freezing and boiling. Celsius, water freezes at 0. Still moving though. Because that's not absolute 0. And then it boils at 100. So 0 and 100. Arbitrary though. We could have chosen ethanol as the scale. Fahrenheit, 32 degrees, water freezes, you know, that's, yeah, yeah, exactly. Except for absolute 0. See, that's by definition will never change. Now, there's a Fahrenheit version of that, and there's a Celsius version of that. It's minus 273 degrees is when everything stops Celsius, or minus 432 Fahrenheit, everything stops. But if we're talking about Kelvin degrees, it's 0. So 2 of them are arbitrary, 2 of them are not arbitrary. They're based on no movement at all. So if we're talking Celsius, negative is fine. We can go all the way down to 273 negative. Then we have no movement. But until we get to 273, there's movement. Even though it's colder than shit. There's movement. Okay. All right. So I got off a little on topic here. We'll talk about temperature movement, but okay. So if your structure looks differently than mine, but it's legal, that's fine. In other words, if I drew that like this, things tumble. That's one of the modalities of motion. And when things move, we have translational movement going from one place to the other. We have rotation. We have vibration. Those are all degrees of motion. All of them combined together are the total degrees of motion. So in other words, I can tumble this around and it does not change the structure whatsoever. So when I draw it in a different position, it's still the same molecule. So for example, on a test, if I said, draw 2 structures with that formula, your structure may look differently than mine, but as long as it's legal, it's fine. Now I'm used to looking at these. I've been looking at these for a long time. So I can tell right away whether yours is legal or not. Just real quickly. If you do enough of these, you get to do the same thing. Okay, so does that make sense? So these 2 structures are the same thing. This carbon here on the top is bound to oxygen and 2 hydrogens. Carbon over here on the right, it's bound to 2 hydrogens and 1 oxygen. Yeah.
So for either writing it that way or that way, it would be considered full credit, or would it be?
Oh, yeah.
more-
No. They're both exactly correct. Same credit. 10 points, 10 points. The point I'm trying to make though is that because things tumble, you can draw them in a tumbled state. Yet still be legal. Okay, so let's now draw another structure that is different than this one over here. Okay, so instead of putting the carbons in the middle, we're gonna throw an oxygen in the middle. Yeah.
Since oxygen has those double the paired electrons, do you have to draw that on the ends?
Yes. Yeah. Understand the point he's trying to make is, do you have to draw the pairs? Every single time the pairs should not be dropped. Make sure you include them. Because they make up part of the chemistry of the molecule. So, good question. Okay, so let's put the carbons around the oxygen. So oxygen, we're gonna go in the middle. Notice I move the pairs again. And we're going to need some room here. And we have we have two carbons. Let's draw those in blue. We have 6 hydrogens. On this case, the oxygen doesn't have the most singletons. It's got more than one though, so there's combinations you can do with it. But if carbon's in there, start with carbon in the middle. Okay, so let's start doing some bonding here. Okay, are there any singletons left over? No. So carbon's got 4 bonds on the left and the right. Oxygen's got 2 in the middle. Bless you. So now we're going to draw the lined version. So this is ethanol again. And this is dimethyl ether. Now, dimethyl ether is used to be used as a anesthesia for operations. When I was 7 years old, I guess, I got my tonsils out. 1957, my tonsils out. And what they did is they gave me dimethyl ether to put me down. They put a screen on my over my mouth, and they took a cloth and then poured dimethyl ether on it, and they put that over my mouth. Breathe that in, and I was out. It's frequently used by gangsters to grab someone from behind and over their mouth you go. A lot of chemistry if you want to be a gangster. Chloroform is different. Chloroform has got a bunch of chlorines in it, where this ether has no chlorines. Chloroform is also put you down. Chloroform is not a nice chemical. They preserve stuff with it. And if you inhale enough of it, it'll start preserving your lungs. Now, when you take anatomy physiology, if you do, you're going to be dissecting a lot of things preserved in something called formalin. And formalin and water, excuse me, chloroform and water make formalin. Yeah.
See,
Offhand, I don't know what it is. I bet you anything though, one of the posters in the hallways here has that as a topic. There's a lot of things that'll put you down though. Yeah. And in a safe way also. These 2 items don't put you down in a safe way at all. Huh? But
You said they gave that for surgery, right?
not.
Oh. I was like,
Maybe when they did.
they did.
yes,
It's H-A-P.
yeah, it's more complicated. And there's also different ways of putting you down. There's deeper ways called general anesthesia and then local anesthesia, put you down a little bit. For example, when you have a colonoscopy, they give you something, put you down a little bit.
Yeah.
And secondly, they give you something to forget what you've been through.
That like laughing gas, like when you get your.
Now, laughing gas is nitrous oxide.
Is that a local?
Yes, it would be considered ones. Yeah. General is you're down. And an anesthesiologist has to monitor you the whole time. Anesthesia is dangerous. That's right. For example, I'm allergic to one of them. And what happens is my lungs stop working. So I always have to tell them I'm allergic to blah, 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 blah. So they don't give it to me. And they don't use it much anymore, but they used to. Now, it's easy to get around. The anesthesiologist, will give you another something to counteract it, and it brings you right out, but they need to measure. Okay, so everyone, listen up now. We're gonna I'm gonna do some more practice on this because we've only looked at single bonds right now, not double bonds, or triple bonds. So let's look at something with, are there any questions about the dimethyl ether in terms of its structure? Now, on the test, I may say, give me two alternate structures for this that are legal. Now, these and the structures have to be different. Just because I've turned it doesn't mean it's a different structure. When I say different structures, the connections have to be different. Okay, so let's do another one. Carbon dioxide. Very stable, very common. So let's do a little structure in it. Okay, so we put the carbon in the middle. Oxygen on either side. Okay, so that's step number one. Step number two is connect up the singletons once. Okay, the next step. Okay, the next step, are there any singletons unpaired? Yes. So pair them up. First step is to connect everything up once. Then check for leftover singletons. Is that in your way? Can you see okay? Okay, so what?
I was so focused on trying to be quiet, I didn't focus about myself.
Thank you for focusing on that, by the way. Yeah.
When you did the oxygen, are the first two, are those paired up or are those single? Cause you kind of just have them like floating around.
Yeah.
I was like, is that one and one and one and what? Where's that? On the left side.
Okay. So we've got two bonds to the oxygen and carbon.
Right, so oxygen has two bond, carbon has four. So there's
So we
one,
go-
2, 4, 5, 6 dots around the oxygen molecule though.
But the pairs don't bond.
Correct, so are your two dots on the left side of your oxygen molecule, is that a pair or are those singles?
On the very, very left?
Yeah, so the right oxygen molecule. Well, I guess we're opposite right now, huh? So there's.
So that's a pair right there. That's a pair there.
Correct.
And because it's. Yeah, so top pair, bottom pair. Yeah, that's what I'm talking. It's a single on each one. So together they make a pair.
are they a pair or are they single? Cause if you could break up a pair. Then technically those are just individual singles all the way.
Well, you can do that with anything. In fact, when we talk about reactions, that's exactly what happens in a reaction. You break everything up.
So I can break up a pair. is what you're saying.
Yeah.
Okay, so that means we're on two different things, right?
Yeah, you can definitely break up a pair.
I was confused when you're talking about two different things.
Okay, so let's go on here. Okay, so carbon's got 4 bonds. 2 doubles. 2 doubles make 4, okay? All right, oxygen has a double. How many bonds oxygen has? Because there's 2 singles, 2 bonds. Either 2 singles or 1 double. Okay, carbon 2, 4, 6, 8. So it's got an octet. Oxygen 2, 4, 6, 8. Also an octet. So it's a legal structure. So now we connect the circled bonds with solid lines. So that's the Lewis structure for carbon dioxide. And like I was saying before, we can move it around, we can rotate it, we can
With oxygen, since. Oh, never. Sorry.
okay. All right, is everyone okay with carbon dioxide? Okay. Now that's the only structure. There are no alternative structures. Now, the more atoms you have in the structure, the more possibilities of alternate legal structures. So. Okay, this guy's got 5 or 6 legal structures. One of them is acetic acid. A bunch of others. So, practice time. Okay, how are we doing on time? Let's see, it's noon. Okay. So, why don't we go ahead and try this on your own? See if you can come up with at least 2. Where do you start?
Carbon in the middle.
However's in the middle, oxygen and then hydrogen on the outside. That's exactly right. See, you answered it yourself. Okay, on the test, we'll walk around and pass the rest of these out. Me first.
And, okay, anyone not spend.
I keep forgetting this. Alex, it's missing. I'm not choosing to know that I did all of my works. I keep forgetting to submit them.
The way to get credit is. Your test is in here.
I hope it's not late.
It will go, but I know you complete. The 30. No, don't worry, it's good.
This is it.
Okay, so let's,
If you see the box, it's on.
okay, so check it to see if it's a little. How many bonds is on? Okay. Put the pressure. How many bonds, you're off. One. Very don't count. Those are. Option, no option, has one bond. One bond.
Then you've got some of that. My bond.
Yeah, yeah.
But typically it's two, one.
Each option has actually. So this oxygen needs to, that needs to get
And all bonded, like, I,
something.
okay.
Should have me to figure it out. Should let me figure it out.
Yeah, you're gonna go to the testing center.
I could take it right here.
Okay. They're expecting you over there. Oh. But you can take it here. Robert.
I really just wanna get it done, 'cause I'm kind of ashamed of myself. I'm very bad, sorry. So. You have confidence.
Oxygen. Two. I only see. Vitamin two.
Mhm.
And vitamin. So you should be there. And then my side. And then
Why don't you?
okay. Yeah, I think it's.
Yeah.
Oh, sorry.
No, so. It's.
Don't know if you wanted it either.
Set lots of times.
And then here, you have a lot of these.
Today's.
That. It's interesting. Yeah. What's going on, so on the oxygen behind.
Four.
It's awesome. It's one of the items, there's one of the code that's. Okay, that's it.
That's fine, you know, we weren't good before.
But now, okay. So,
Don't erase it though.
I should have. Oh.
Um. Yeah, that's good.
I got it.
Here.
So what I do with that?
If you put the lines in, where it needs to be signed.
Okay, you just know.
I got,
Four.
yeah, I got it.
And then if you wanted this. I make it. This.
So part of one with just the hospital, the common, we start having. This is the one. The three bonds are. So it's six falls. They're on those. Yep. This is to. Oh, that, those are you, that's yours. So I need to. You are the.
Yes.
I just call this actually what I was. Yeah.
I mean, when it's like.
There's
so. When it's like.
So you want.
It's,
Yeah.
I know. It's the. Here's the thing. That's scared. I'm picturing that. That's just. It's like, it's your.
And for you, it's.
Yeah, I'll be like, those kind of things. I don't know. I want to do it to your own state. Just. Like.
It's where you have this.
So I want.
You let me all be.
Oxygen, food.
The sequel word.
I'm very well.
Lives, oh, two volumes. You sing.
Yeah.
Yes. It's like,
Again, yes, it's very.
Also.
Yeah. It does. How many of you guys know? How many? This is what that's like the different like setups. I've been to. It's not.
What are you, sorry, let's go. I have to take care of that.
I don't know if this.
He almost had it, this is it.
I don't know how to write. Oh, yeah, true. So there's the private school.
And I mean, it's not just simple, so.
Yeah.
Like, it was like two. Going up to, maybe when they're out, on the other side.
I say I've been having it already.
Yeah.
It was one for my first year. Or,
Right. But like, could you like say it line?
Yeah.
Yeah.
Would be like, and be like variations, like instead of putting it. No.
Yeah.
With them, yeah, I think. Yeah. Like, you see how these two are set with the year.
Yeah.
This one.
Right.
Which makes sense.
Those things can go on,
It's black.
Yeah. Now, yeah.
We can, you know.
It's just is it fire? If it's on their story or it's.
Like, we can use that. There's no other. Like, it's like an old, you know, rules. Like,
It's just like nine
Oh, like,
stories.
you know.
This.
I'm not.
visual.
I'm not.
Those are sort of the same.
Yeah, but they actually different. So that's the listen. Yeah, it's like.
Sorry?
Yeah.
That's fun. I don't know. I've never been.
The only.
No,
Yeah.
So, I would be like those house.
So I think there's an app. Argument.
So,
Oh, okay.
Or it doesn't really.
Okay, I think argument, okay, so I think it is like. You had to build a message. With this word.
only have 2 lots. So this in here has 2 lots. In here. So, yeah, this one, on your first structure, you said, instead of hydrogen, it's like the way compared to it's like. That's, see it.
Like, what am I talking about? Like. Like, oh, yeah. This is my issue.
Except for. And. Well,
He's like a better kid.
It's a part of that.
Oh, that's. It's only like half of the. Oh, I think this one.
Okay.
It's not his video, but it's only of the shoot. He does like, he like writes this file. And then it's showing. Oh, no, I think it's true. I think I yeah. It's. Very happy, my wife, to think of that, but the stuff. Yeah. Because I don't she refused to write it. She write the first one and then they said, you know, the images we want and just and then it like. And then it reading on it. It's also very least in his hands and it's for these crystals. Okay, great, that's through, which tends to success.
Oh.
Oh. That's why he not it. Unless you need to use it up for six. You mentioned, that's what he has. She's not bad, it's not like she's all was that's not, yeah, it's not, it's not, it's not. Yeah. See, man, yeah. Two different things, I don't know. See, you have different properties. Oh.
It's like the baby. It's the baby. Professor, and I wanted to talk about it. I don't even know these.
I connect the oxygen to the oxygen. But can I do it all the way? Right.
It should be correct, because. That, but I'll get it. Yes, it's great.
Yeah, I'll be using it.
It's a matter of. In the beginning of my piece.
Why do we need for my son? Like. No, me too. It's a lot.
Can I grab my conversion table for the test question?
Oh, yeah.
Right.
Like there's just one. That's great. Voice and how many times that two? This is well, we need by often. Someone broke it.
Oh, what? These were. Yeah, as long as you understand it.
It's like that if it's in the grade. So if it's if it's like you look at another road and you all are the person acting like double blended with double spin. What if it's not double? Or. Oh, it's like.
No, see, we got just been doing my thing. They see on the side, you know, I'd be like, there's
Like, you know, it's like, so, it's.
One more.
Yeah, I was over that part of it. That's how I put it. All the way to three places, you know, didn't anything. Oh, I think what I did is I got to leave back in. Like the lot. Okay. Yeah, so that's what he said here. So, this, oh, that's. Sorry. Okay. Thank you. Guys. At least this. Yeah. So there are, I just on Earth and. It's funny, so, yeah, this thing, it's very bad. But instead of going to the section like so like so yeah. Okay, what I was thinking was like with the oxygen has one higher. You're gonna run it. Like really little. That's why. Yeah, that's not kind of what I'm thinking. Have to either go to or inboard, but I'm thinking get it. Really don't do something higher. You get it. Because like it's like the last thing. Either four and it's.
Well, I think for me, my string underneath my bed. So.
I think there are like six. I will just have to find another.
Okay, well, if not, I can go and use one of the other rights for cleaner. I just have to stick with those. Unreadily. Oh, yeah. Cause I even brought me gravel sewing kit.
Wait, it's not the one. If you. Thank you.
Yeah. See your question? See? I brought my little
Whatever.
I know, I made for you though. Yeah, I didn't know where you're from. Okay,
One after.
I just wanted to do whatever you do.
Okay, that's really, this is like that, it's really awesome. Ran two.
So this is one fun. I think that we welcome some. So it's in
Carter can, those things.
Right.
One foot on the same, yeah.
Okay.
So. About macro fever.
Wednesday, we put in first. And for this. Start with given, we then look at kind of fractions and different. Given it always has to cancel. Looks at. I mean, that's the first fraction, given has to be in the bottom.
I get that part, it's just the fever, it's like, putting them in. The brains. I was like, do I need to go back to algebra? I mean, I guess it's like still. Terrible. Well, the longer one.
Okay. Keep doing. Starting. They're not gonna be necessarily. On the beginning of the people. Probably. For sure. So. 2 steps. Slow.
Early on. And yeah.
You stick with the class. But you will later. It's C.
But that's what we do is. Hey.
The center is
Look at that.
great. Very rough. Stick with. It with this. Stick with the outward words. Separate. That's the only purpose in life is very.
So say this last again.
That. Okay, here we go. So, give a moment, right? Let's start.
I've been that dream. I'm serious, I'm not even joking. I don't know.
It works.
Just one.
Extra.
So this.
This year.
Okay, thank you.
Better.
Yeah, so it's all right.
Yeah,
Okay.
it's fine. Okay, just. You can go from here.
Yeah, yeah.
Um. Yeah. So. And then we have. I did, I lost it, so yeah, so. Long. Further to the one. I don't know for that's the sweat. Okay. But you need what it's.
Yeah, mine is when we did, we got put in a box and somewhere in the garage. Well, it's gonna take some, I gotta, put it again,
I can.
yeah, no, he did, no. I know what, I know. It looks like fur, but look. It is a pink. He was like, I want to go to the market, he said, here in Hillwood, place, I want it pink. I didn't make that coffee, Marvel. Basically, just bottles.
Where did you see? I think so, I mean, these were the questions that were gonna be on the test and I've been doing. Practice test? Yeah, I tried doing it in the practice test and listen. Baseball, that's. We gotta do it, yeah, right.
Oh.
Yeah, you know what, it's, nice. Might be, yeah. Well, and I'll have conversion factors would be. What was the problem? Interactive with one. Another one. But.
Oh. I think it's the same. Right. I don't want to do it. Well, in the meantime,
Okay. That's fine. We're talking about different modalities. So my teaching modality is not actually learning today.
Could also try. That's what I think I'm gonna do. I'm gonna go watch some videos. The last unit one, understood your teaching for unit one. This one, my brain's not off. For whatever reason. Maybe one of them will say.
And Wednesday.
I think this
Thursday-
is difficult.
Wednesday, Thursday. Maybe it's chemistry. Remember molecule, polar mass, and all that stuff. So this could be. Why I wanted. You get good start on unit one. Concept of conversion. That's given we.
I know, and we're just gonna get deeper into it. I'm just really scratching the surface.
You'll do fine.
All right, see you around.
Yeah, at these days. That's fine. But.
Okay, that's good. That's good. This is called an ester. And you have COCO. And this is called peroxide when you have two oxygens together. Then. Okay, so continue to modify this one where you have a double bonded O and a single bonded. Move stuff around in this here. That'll get you yet another one. Good. But those all look good.
Yeah, I'll look into it. Is there like a certain number of combinations? Like, you know,
There's probably a way to do that. I don't do that, though. I just go, I've been doing this as an example for decades, so I just know there's about 5. Possibly even 6. Doing great.
thank you.
Okay, and let me.
Hey, Professor.
Yeah.
I wanted to just tell you, because I know that you know that I've been showing up late for like lectures and such, and that's I prefer to I like do night owl stuff. And that sometimes affects my wanting to sleep in the morning. So I end up not intentionally sleeping in, but I make sure to watch your YouTube lectures.
I figured you've been watching the videos. So.
Yeah, I just make sure I do show up to show effort. So, you know, not be a ghost. Such.
Here's the test, and it's. Did you see the take home test?
Oh,
Huh?
the conversion factors, I do have one of those for the.
There wasn't a question on here, just a fact, it was just a converted table.
What? What do you mean?
There wasn't any questions on the page you gave me.
Right,
Take home questions,
this is the take home test.
feed it to me with the real test.
Okay. Yeah, this is just converted.
So do you want me to do this? Okay, because you gotta use it for. I thought this was taken.
Line is similar to this.
Well, no, I mean, like when you told us to grab take home question, I grabbed that instead of. The,
The take home question was online.
what I thought why I didn't do it, because I thought it was different. Yeah, I always expect paper, because when it's one way, it's usually all the way, if it's the other way, it's usually all the other way. This whole hybrid mix mess is really just mind blowing.
Um. And just keep that until you get it over, okay?
The testing center did.
You know, if you're going to the cafeteria,
Yeah.
you go to the career transfer building.
Oh.
That's what I guess they're using it for, but its main purpose was the testing center.
Okay, sure. Can't do a testing center because I didn't do a proctoring sheet for it.
Yeah, one of the girls who had the SAS, on the actual test day, came out and said the same thing. Yeah,
So I have to pull out a proctoring sheet, so, on the next steps that you want to test, do you have accommodation?
Like,
he can go to the library, right? Go to the first come first served study rooms, right?
Yeah.
That's like a private testing center room. It looks almost identical to the testing center's private rooms.
Or you here. And then,
like,
and then you give it to me tomorrow.
That's what I'm doing.
I take this over.
That's the test, sorry.
Okay, and I was like, take it.
We can hold if you want.
Okay,
I mean, where else will we leave it?
I thought I would give it right back to something.
Today, there's no line today.
Guess what? That's Thursday.
Yeah, because it's holiday on Thursday.
You need to make it fair for the other students.
So the Monday, Wednesday, we already have the two labs, but Thursday people. Because at Thursday, got one I had run that week, so.
Get this right back.
Lots to take.
And it.
Very much. All right, good. Okay, so you want to take my laptop on?
Oh, yeah. A double bag, so you can literally just put it in my other long bag.
Okay.
Double bag for a reason. So you never know when another bag comes in handy. Or you never know when you accidentally broke a seam on your canvas tote bag. So you need
So
something.
this has got a bunch of junk in the pocket. First, dump those out when you're gonna put it back in.
I'll put them in zippies. Because I'm only gonna be needing that one pocket that has the hole in them.
I think that's the only place I have the hole, is in the pocket, the left pocket.
Well, once that's fixed up, you can use it again.
Well, I've been using it,
Well, you could put like
Hole-
paper clips in it or something.
holes and all.
I mean, like you can put tiny things like little paper clips or like, I don't know, whatever chemists use.
All right.
But I'm sure paper clips so much handy when you're giving out work. You're like handing out packets and then you're out of a stack and then you put the paper clip away or something. I don't know. Some teachers have different methods. Good.